Let's take another question. So that the function defined by fx equal cos of x square is a continuous function. So that the function defined by fx equal cos of x square is a continuous function. So how will you do this? Because cos of x square, this is a composition of two functions. Previously we have learned composition of two functions. Okay, so let us start solution. Fx equal cos of x square. We will write like this. The given function is fx equal cos of x square. Okay, this function is defined for every real numbers and f can be written as the composition composition of two functions f equal GOH. Okay, where g of x equal cos of x and h of x equal x square. Now you see fx equal cos of x square. Here there is a composition of two functions. The first function I have taken gx equal cos x, and the second function I have taken as hx equal x square. Okay, now you can prove this. How will you prove this? You see this. Since GOH of x equal g of hx equal g of x square equal cos of x square equal f of x. Okay, you've got the functional value. Okay, GOH of x equal f of x. Okay, f is a composition of two functions g and h. Okay, so you have got this. Now this since GOH of x equal h of x, in exam you need not to write. Okay, if you want to write, you can write it, no problem. Now let us start. It has to be first proved. What will you prove? That gx equal cos of x and hx equal x square are continuous function. If we can prove gx equal cos x is continuous and hx equal x square is continuous, then according to algebra of continuity, what you will get? What was the algebra of continuity? Third one, f into g is continuous at x equal c. Okay, if the function f and g are continuous, then their multiplication are also continuous at the point c. Okay, now it is evident that g is defined for every real number. Okay, let c be a real number. C is any point on the number line. Okay, so I have taken let c be a real number. Then g of c equal, because the function gx equal cos x, so if I replace x by c, what I will get? Cos of c. Put x equal c plus h. Previously I have told you can put c plus h or c minus h, anyone you can put, okay, but do not write both, okay. If x tend to c, then h tends to 0. If x equals c, then c get cancelled, so h equal 0, okay. Therefore limit of gx when x tends to c is equals to limit x tends to c. What is gx? It is cos x, is equals to limit when x tends to c, when x tends to c, h tends to 0. So next I will write h tends to 0. You can see if this is x, this is x, so if this is h, it should be a function of h only, okay. So replace this x by x equals c plus h, so cos of c plus h, okay, equal limit h tends to 0. Now this is the formula cos a plus b. What is cos a plus b? Cos a cos b minus sin a sin b. So cos c cos h minus sin c sin h, okay. Now separate it. Limit h tends to 0, cos c cos h cos h minus sin c sin h, okay. No, not sin c sin h, it will be limit, okay. Here the limit is missed, minus limit h tends to 0, okay. Limit these two you can separate. Limit h tends to 0, h tends to 0, cos c cos h, cos c cos h, minus limit h tends to 0, sin c sin h, okay. Next equal limit h tends to 0, cos c cos h minus limit h tends to 0, sin c sin h, okay. Now put the limit 0 cos 0 1, so you will get cos of c minus, if you put sin if you put the limit here, sin 0 is equals to 0, so you will get 0 only, is equals to cos of c, and cos of c is equals to g of c, okay. Therefore limit x tends to c, g of x is equals to g of c. So this is the definition of continuity. Therefore gx equal cos of x is a continuous function, is a continuous function, okay. Now second, for hx equal x square, you have to prove hx equal x square is also continuous, okay. Clearly h is defined, similarly h is also defined, okay. It may be continuous, it may not be continuous, but h is always defined for every real numbers. Let k be a real number, okay, means the point, okay, on the number line. Let k be a real number, then what you will get? H of k is equals to k square. Therefore limit x tends to k, h of x is equals to limit x tends to k. What is the function? X square, x square. So put the limit, you will get k square. So and k square is equals to h of k. Therefore, limit x tends to k, hx equal hk. Therefore, h of x is equals to x square is a continuous function. Okay. Now, according to theorem, what was the theorem of composition of function? Remember? Did you remember it? So see, it is known that for real valued function small f and g such that FOG is continuous at C if G is continuous at C, and if F is continuous at G of C. Okay, then FOG is this will not be continuous. Okay, this will be defined. This must be defined. FOG is defined at C. Then FOG is continuous at C. Therefore, Fx equal GOH of x equal cos of x square is a continuous function. Okay, so this was the proof. Okay, next question will proceed. So that the function defined by fx equal modulus of cos x is a continuous function. Okay, so let's proceed now. Similarly, this is also a composition of two functions. One is cos x and one is modulus of x. Okay, so let us proceed now. What will you write now? The given function is fx equals to modulus of cos x. Okay, this function is defined. I've told you it is defined. It may be it is always defined, but it may be continuous, it may not be continuous. Okay, so this function is defined for every real numbers, and f can be written as the composition of two functions. F equal GOH, where first function, what I will take, gx equals to modulus of x and hx equal cos of x. Okay, first function I have taken gx equal modulus of x and hx equals to cos of x. Now it has to be proved. It has to be proved that gx equal modulus of x and hx equal cos of x. Both the function are continuous function. It is to be proved that gx equal to modulus of x and hx equal to cos of x are continuous function. Now, for it is to be proved that gx equals to, okay. Now, gx equal modulus of x can be written as gx equal, what is modulus of x? This is two function. There are two functions. One is x when x greater than equal 0 and the other one is minus x when x less than 0. Clearly g is defined. Okay, g is defined. I've told you g is defined. It may be continuous, it may not be continuous. For all real numbers. Okay, now let us take a point. Let C be a real number. Means the point on the number line. Okay, let C be a real number. So there will be three cases. Okay, the first one is what? This can be, the first one is x greater than 0, one is x equal 0, and the third one. This is first, second, third. Okay, so there will be three cases. The first case, case 1, if C greater than 0. Okay, if C greater than 0, then g of C, what is gc, is equals to greater than 0. So the function will be the first one. Okay, so this will be g of C equal C. Therefore, limit x tends to C, g of x is equals to limit x tends to C. What is the function? Because this is C greater than 0, means the first one, x greater than 0. So it will be x only. Okay, so this is C. And what is C again? This is equals to gc. Therefore, g is continuous. G is continuous at all points. At all points x such that x greater than 0. Because this is C. So at last what you will write? X greater than 0. Okay. This is first case. What is the second case? You can take C less than 0 or you can take C equal 0 also. Okay. Then g of C. What is g of C? Now C less than 0. So the function will be the second one. Okay. So minus C. Replace x by C. So what you will get? Minus C. Therefore, limit x tends to C. Okay. G of x is equals to limit x tends to C. What is gx? Minus x. So this is minus x. Okay. Is equals to limit x. Not limit. You can directly put the value. Okay. So you will get minus of C. And what is minus of C again? G of C is equals to G of C. Okay. Therefore, G is continuous. G is continuous at all points. At all points x such that x less than 0. In the third case, case 3, if c equal 0, x equal 0, okay, then comma then f of, not f, it is g, okay, g of 0 is equals to the first function you will get, because x greater than equal 0, so there is x equal 0 also, okay, so you will get g0 is equals to 0. Therefore left hand limit you can write, therefore limit x tends to 0 negative, g of x is equals to limit x tends to 0 negative. What is the function? 0 negative means less than 0, okay, so you will get minus of x. What is minus of x? You will get 0 only, okay, after putting the value limit. Again, limit x tends to 0 positive, gx is equals to limit x tends to 0 positive. So 0 positive means greater than the value of x greater than 0. So what you will get? The function you will get as x, okay. So putting the value you will get 0. So you can see left hand limit, right hand limit and the point are equal. So the function is a continuous function. Therefore g is continuous. G is continuous at therefore g is continuous at x equal 0, or g is a continuous function at x equal to 0, okay. Next, what you will write? From the above 3 observation, because there are 3 cases, so 3 observation, okay. From the above 3 observation, it can be observed. What will you observe? Observe that g is continuous at all points. At all points. Similarly, for hx equal cos x, you can proceed this one. How will you proceed? Similar to the previous one, okay. So it is evident that h is defined for every real numbers. Every real numbers. Let c be a real number. Let c be a real number. Then h of c is equals to cos of c. If you replace x by c, you will get cos of c. Okay. Then h of c equal cos of c. Put x equals to c plus h, or you can put c minus h, anyone. Okay. If x tends to c, then if the value of x equals c, then c get cancelled, so h equals 0, so h tends to 0. Okay. Now, therefore, limit x tends to c, h of x is equals to limit x tends to c. Okay, what is the function hx? Hx equal cos of x. Okay, so put here cos of x is equals to, when x tends to c, h tends to 0. So we will write here limit h tends to 0. So when this was x, So when this is x, this must be a function of x on h only. Okay, so this is replace x by c plus h. Cos of c plus h equal limit h tends to 0. So what is cos of c plus h? Means this is the formula of cos of a plus b. So you will get cos a cos b minus sin a sin b. Okay, now you can separate these two terms. Okay, equal limit h tends to 0 sin of, not sin of c, what it was, cos c cos h minus sin c sin h. Okay, is equals to limit h tends to 0 cos c cos h minus limit h tends to 0 sin c sin h. Okay, is equals to, now putting the limit, cos 0 is equals to 1, so cos c is constant, so this you will get as cos c only, minus putting the limit sin 0 you will get 0, so sin c into 0 is 0, so you will get 0, is equals to cos of c. And what is cos of c? This is h of c. Okay, therefore hx equal cos of x is a continuous function, is a continuous function. Okay, so gx was also continuous, hx is also now continuous. Okay, so if two functions are continuous, their multiplication will also be continuous according to algebra of continuity. Okay, so last what you will write, it is known that for real valued function f and g such that f o g is defined at c, and if g is continuous, this g is continuous at c, and if this f is continuous at gc, then this FOG which was defined will be continuous. FOG is continuous at C. Okay, therefore fx equal GOH of x equal modulus of cos x is a continuous function. So with this we have ended this video. Okay, so good night.